Hello and good afternoon. Can you hear me? We are a very small class, but that's not going to make any difference that I'm going to be broadcasting through YouTube, so you should have a YouTube account to be able to comment in the chat and communicate with me in the group. If you don't mind, I was going to share all the group emails, the emails of the group with everybody in the group. If you have a problem with that, let me know. Okay, it's a very small class. And I'm going to be using this mode of broadcasting because it's most efficient and I don't have to share files. They're all up there. Everybody knows YouTube. And I guess I just had enough bad experiences with other platforms. So, welcome to Statistics Verano 2020. Although I have not prepared the Moodle page, I will prepare it. I want to run through what's on the Moodle page. And I should have it up tonight. Let me show you what you've got there. So you're watching the Moodle page. So here we have, this is last semester. So I'm just going to take most of the elements of here and leave some things behind. I'm going to put a schedule up. As we discussed, or as I mentioned to you, I'm going to, okay, this is the best way to show you. I'm going to broadcast on Tuesdays and Thursdays. The notes will guide you pretty much through the material. Most of the course is in video form already. The playlist has, if you scrolled through, you saw all of the videos there. Those are from the lectures last semester, but I also have videos that were edited. They weren't live streamed. They much cleaner versions, and they are instructing with the notes, the same notes that you're going to use. So this course has 6 units. We agreed that Saturdays, or most of you wrote me and said Saturdays was fine. I didn't get anyone with a problem with testing and quizzing on Saturdays. So it's a very fast-paced course. So I'm going to have to leave a lot of the self-study to you and motivation. And just on Saturday, this Saturday, I will give some exercises over the 3 hours I mentioned, 3 to 6. So there'll be quiz problems for all the units that we touched on. And then next Saturday, I will give the first test. And then the final Saturday, I'll give the final test. That's it. That's all we've got. So hopefully you're ready for this. You have all the materials at your disposal, but it's a matter of going through them and watching the videos, pacing yourself, sitting out, allotting enough time to review things. If you plan to be studying at the same time as working, you may have a problem unless you have particular experience with statistics, because there's just a lot of material to get through. So I tried to have this set up for Verano Largo. I don't know what happened, but it is a Verano Corto session. So let's see if you have any comments. You can let me know. Good afternoon to everyone. So here's the Moodle page, how it will appear. There's 6 units, you see. Unit 1, Design of Experiments. Unit 2 has 2 parts. graphing and descriptive statistics, and then normal distributions. Unit 3 is regression. Simple regression will be the focus. Then there's material for the midterm that you can start studying for. Then probability. Unit 5 has also 2 portions, one on binomial distribution, the other on sampling distributions, and finally an inference unit. So can you see all that? Hopefully you can see all that. And when you open each unit up, and I'll give you a layout of which ones you have to study which week. In each unit, okay, you have to scroll past the header. I have to delete all this stuff for you. Okay, so this is what you're going to get. You get lecture notes, which you will read and prepare. There will be exercises throughout the notes, so problems with blanks you can fill in. And then the answers to the lecture note problems will be in the annotated notes. Then there's a package here of homework exercises. So you prepare those on your own. And then there's practice assignments. So all of this is self-study. All right, you're just going to practice. Then there are some quizzes. These quizzes are automated and marked, graded by the system. All I want to see is that you're attempting them. Now you have the opportunity to try them as many times as you want to earn 100%, right? So they're for practice. And they are in every unit. I have some, and sometimes I backtrack. So with a unit 1, I just have unit 1 questions, but in unit 2, let's see what I have there. In unit 2, I have quiz problems for unit 2, and then, so same thing for unit 2. So here in unit 2, same thing, lecture notes, annotated notes, that means the answers to the lecture notes. Any questions I ask will be, the suggested answers are in the annotated notes. Then there's this package called sample problems. This is important for us to review. So I suggest you watch me on YouTube and you open up also a page so that you can view the notes. Ideally, you'll print out all the notes and put them together so you can read them from paper, but it's up to you. I recommend you print all these items and have them in front of you, but that's up to you. And again, there's homework exercises, so those are all for yourself. And here are, look at this, all the videos these are the videos that are linked in YouTube. I've numbered the videos, and I've also given you the page numbers that the video covers. So you notice 8, 9, 10, and then I jumped to 14, 15, 16, 17, 18, 19, 20. So most of the pages are covered in video. So there's most of the instruction here. So when we meet, what I'll be doing is reviewing the pages not already prepared in video, or emphasizing some points, some topics that I think require some emphasis. Also, we'll solve problems together, right? So use your time in the evenings, even though we're not meeting. Get going on the studying. Here are some practice assignments for Unit 2 and quiz problems. So this is the first part of Unit 2. The second part is the normal distribution. So same sort of thing. So this is what I have to finalize for you. So here you have the same sort of thing. Lecture notes. These are solutions. So For Unit 2, you don't have an annotated set of notes for the lecture notes. You'll have to do that on your own, so I suggest, like I did already, print the notes up and mark them up, put out your solutions. Here are some answers, and then all these videos that link to YouTube will solve the problems in the notes. Okay, so you can watch them. There's a total amount of videos I calculated. Now I can't remember exactly, but it's a lot of hours. You have 70 videos total to watch in YouTube. So let me check. 70 videos. They're between 5 and 20 minutes. Yeah, so it's like a lot of hours of videos. I added it up once, but I don't want to tell you now because I want to be sure. I'm going to have to check it. So anyway, there's lots of hours here for you to watch in video. Again, you have some quiz problems. You have some NOR quiz problems here. So that's that. So what you're going to be doing is just working through the notes, answering the questions, and then please email me either with a photo of portions of the notes that you don't understand so that I can review them when we meet on Tuesdays and Thursdays, okay? So that's what I want to use Tuesday and Thursday for us to engage and you to get further clarification of concepts and problems you didn't understand. As well in Moodle, there are old exam problems. So you have lots. You have the midterm problems on the next one. So you have old midterms that you can study from as well. Okay? So everything's here. These are all old midterms and the solutions. So it's a full repository. You just need to find time to review all this. Okay, so today I sent you a pack of notes. They are the notes in Unit 1. So I'll go back to Unit 1. I can find them here very easily. Unit 1. I still have to scroll past all this. I need to delete all that. I put that there so the students could see those things. I wanted them to answer questions. I wanted them to try. Okay, so we begin with DNS, Unit 1. Unit 1 is about designing experiments and sampling. So actually collecting data and good data. What constitutes good data? So this is where we're going to start. And what goes along with this unit are some videos that we have permission to broadcast for the use for educational purposes. So I'm going to try and broadcast them. What you're going to, I just want to say a few things first about the notes. And we're going to talk about a few things, and then you'll see you can't see that, can you? How do I make you see that? I'm going to show this in my iPad anyway. So in these notes, that's too big. Okay, no. I'm going to show you the notes in a different way. I'm going to demonstrate hold on, I'm going to bring them up on my iPad. Let's see how long this lasts, this connection. If I lose a connection, just hang on and I'll come back. There you go. I apologize, just looking. Where is my file? There you go. So I'm just pulling up the notes. So what is statistics? That's the first question. It's slowly loading, sorry. What is statistics? What is a statistic? Can you answer me in the chat? What is a statistic? It's loading very slowly. Anyone, what is a statistic? I'm not sure why it's so slow. think it might have froze. Okay, so a statistic is a metric. A statistic is a measurement to gain information. You guys are not getting exactly what a statistic is, but you're kind of around it. Okay, so this isn't working. I'm gonna have to do something here. Yeah, it's frozen. Okay, I'm gonna have to come back. We're gonna pause and I'll come back. All right? Just read through the notes while I'm gone. I'll be back in less than 5 minutes. Okay. Okay, I'm back. I think I'm back. Am I back? I can see the stream. No need to panic. I just had to fix my internet connection. All right, so you can see the notes. It's from my iPad. And I asked you the question, what is a statistic? A statistic is a number computed from data. It's a number computed from a sample, particularly, of data. Okay, so it sounds simple, but okay, I'm saying a lot. I am saying a lot. So you want to know about something. You want to know the characteristic of some kind, of a person, a place, or a thing. And you have a target population to consider. So let's say we were interested in grades. Let's say grades of MBA students. So you could just say MBA students at the UPR, right? So that could be my population. So all of them would be in my database, my population. But let's say I just looked at a sample. A sample is just a few members of the population. So I'm going to target the population, the MBA students at the UPR, and I'm going to particularly look at the ones in statistics, in MECU 6551. So we can argue if that's a good sample or not, but those are the ones I have the grades for in their class. Okay, so I have grades for people taking 6551, and otherwise there's a whole bunch of other students taking that have taken, let's say, 6551 before. but I'm only going to focus on the ones in my sample. So if I'm interested in the grades in the stats course for all registered MBA students, just taking a sample gives me an idea, right? And it's efficient because I have those numbers right now, and I don't know if it's representative or not. We can argue if it's a very good sample, but that's the idea. All right, so I'll just say example. So what I'm saying here, let me for a variable of interest or characteristic, the grades in MECU 6551 at our campus. So yeah, you're going to see my writing's not so great on this thing. So you're going to depend on the notes, the nicely written notes. This is just my iPad. So what do I want to know about the characteristic? So I want to know what to expect, right? I want to know what to expect in terms of grades of students taking MECU. And I could say, well, I want to know what's the average that students get in that course in general. So if I had information on all the students, I could actually get that for the entire population. But just with a sample, I'm only going to collect, I intend with the sample calculation, just a group or just one class of students. What I'm trying to do, what I'm attempting to do, is speak about the population. So what I'm doing is I'm calculating a statistic where a statistic can be computed from the sample information. Okay, so I can calculate an average as an example. And what is my goal? My goal is to estimate I'm going to try and do this. You'll see my videos that are edited are much more legible. So the parameter, the actual average of in MECU, in the stats course, is estimated by the statistic, the sample average in MECU. So the example that I'm going to give you is the population average. We call it a mean. Which will be estimated by a sample mean. And because we use these a lot, we have particular symbols for these things. And we'll get into all the symbols, but that's the idea. So a statistic is a number computed from sample data. A parameter is a number computed from population data. All right? So why do we do this? What's the goal of statistics? The goal of statistics is to gain information from data about a variable so that we can better, and the goal, ultimate goal, is to better understand what we can expect. Okay, so we, from a sample, can imagine, if it's relatively representative, we can say, well, from this sample, we found that the average grade in MECU was a C. So if we continue using the methods that we've been using, we can expect a C overall in the population. So we should probably change something or do something or better prepare students so that doesn't happen in the future. That's the idea. Okay, so we want to use a sample to give us a better idea of what to expect, and so we can take action, either to prepare or change the outcome if we can. All right, so in general, there are different types of data. Now, the type of data that you're working with will determine the kind of statistics you can calculate. It's not always the right measure, it's not always the right computation to calculate an average or a mean. And we'll get into that next class. But for now, there are broadly speaking, two types of data. And I illustrate the difference in types of data with this example. I give you 4 different variables, where variables are a variable is the characteristic of a person or a thing that can be expressed as a number. That's called a variable. So the variable for the example I gave you before was grade. Right? Grade in a course, in a statistics course. So variables take on particular values, and the value should be a number. So let's see. What are the different kinds of variables? Well, here are 4. Favorite restaurant is a variable, number of passengers in a car, temperature, and performance rank. And what I want to do is understand what separates these variables. Why did I pick these ones? So let's take favorite restaurant and performance rank. Favorite restaurant would be like you would be collecting, in that case, names of restaurants. So however you collected it, with a survey online, or you called people, or you asked people in the street, what's your favorite restaurant? You put that information into either on a sheet of paper, or then you enter it into a computer, into a software like Excel, and you would have information like so someone could say, oh, well, Chili is my favorite restaurant. And the next person that you asked, however you approach them, is going to say, Popeyes is my favorite restaurant. And some people say, oh, no, my favorite restaurant is, what's the name? I'm thinking of the one I like. Viejo Almacén. If you've ever been there, it's so good, and they do delivery. Viejo Almacén. All right, so you get the idea, and then the next person happens to say Popeyes. So this is the data. But these are not a number, you say. So what you have to do any sort of analysis is to code these as numbers, or you can imagine, so this would be my Excel spreadsheet, and then beside it I could recode it. I could just call it FR for favorite restaurant. And then I could say Chili's gets a 1, and Popeyes is 2, and Viejo Almacén is 3. So whenever I see those, I use the numbers 1, 2, and 3. Oh, Popeyes again, so that's 2, you see? So that's how it goes. And then I collect information. So that's my data. So that's data for favorite restaurant. What about data for performance rank? What would that look like? Performance rank. So performance rank, let's say you have running a business and you have various departments, and then you have a record of who in the performance evaluation, how people ranked. So who ranked first, who ranked second, third, etc. So similarly, I can move this up. You have another column. So performance, I'll just call it rank. And you go to the first person. You can go alphabetically maybe, and identified what rank were they in the department. So let's say the first person you ask is 12th, or the one you investigate is 12th ranked, and then the next person is 10, and then 2, and then 1, okay? And this would be the number. These would be the numbers for performance rank. So what is similar between these and what is different? They're just numbers, right? Any thoughts about these numbers? Well, so let me ask a question. If Viejo Almacén is 3, does that mean Viejo Almacén is better than Chili's? Popeyes is 2, does that mean it's better than Chili's? Like, what do these numbers mean? Do they mean anything? Does the ordering of the numbers matter? When the ordering of the numbers doesn't matter, so I just used 1 because it came first on my list, and I used 2 because 2 came next on my list. If it was somebody else and they were collecting information, they would have assigned the numbers even differently. Maybe Chili wasn't going to get a 1. So when this is the case, the values, or this variable, is known as a nominal variable. Nominal for no or little. Okay, little information. You're getting the least amount of information from this variable. Now it's nominal in the category, or in this type of variable known as categorical. So we would say this variable is categorical and nominal. Rank then is also categorical in that the way rank is determined, many things go into performance rank evaluations, and you might have several individuals making their opinion Okay, so you might have different supervisors, or you might have one supervisor and then you might have information from colleagues or peers in the department. So all this information goes into computing the rank. There's not like a scale that an employee can stand on and it tells us what their rank is, or it gives us a score. Okay, there's no quantitative way. It's really much more subjective. When data is subjective, just like it was for the favorite restaurant, it's also categorical. But the difference is that between these two, favorite restaurant and rank, the ordering for rank does matter. So the person who was first ranked did better than the person who was second ranked, and so on. Okay, when order matters, we refer to the variable not as nominal, but as ordinal. So there you go. So those are two types of variables. Under the heading, under the type categorical, you have the subtype nominal, and you have the subtype ordinal. Now these kinds of variables are different than the other ones I mentioned. The other ones are temperature and number. Let me verify. What did it say? The other ones are temperature and the number of passengers in a car. So let's look at these. So you observe, you use a video camera footage. Video camera footage to observe how many people in a car, count the number of people, and you record it. The higher the number, the more people in the car, and there is a limit because you can't have, cars can only be so large, okay? So this is just for cars. We're not going to include vans, or no, well, vans, but I mean we're not going to include trucks and buses. That's what I mean. No buses or large passenger vehicles. Okay, they are commercial passenger vehicles. These are for passengers in a regular type car or SUV. So the number of people in a car, passengers in a car, is different from temperature. How? How are they the same? How are they different? Any comments? Number of passengers in a car. So what will that look like? Let's go back to our list. This is really important, is to imagine what it'll look like. Okay, so the next column, let's say, is number of passengers. The number of passengers in a car would be like, well, the driver's one and the passenger, we could say if there's passengers, it's either 0 or one other person, or maybe 4 other people, or the next car has 2, okay, and so on. Temperature, depending on the precision of your barometer, your measuring tool, it could be pretty precise, right? You could get 22, well no, it's warmer than that here, 26.5 degrees one day. You can get 28.8 another day. You could get 29, okay? So you should see here that the difference is going to be, although different people counting the number of passengers should come up with the same number. And different people using different measuring tools for temperature should come up with the same value. So we call that, when it's objectively determined, we call these both quantitative. So these are quantitative, different from the categorical ones of rank and favorite restaurant. But there is a distinguishing feature between the two. In the case of passengers, you can't have a fraction of a passenger, right? It's only whole numbers that you can use. So we have a term for that. It's called discrete. And for temperature, we have a term for that where fractions are permitted. Where fractions are permitted or allowed, or even though you don't have the right tool, you could get one to be more precise. We call that continuous. So those are the different types of variables we're going to focus on. There's 4. 2 categorical and 2 quantitative. So I think you have a good idea of that. I can imagine. So what I want you to do is try the exercise that follows this introduction. Let me just walk through what the notes say before we do that. So quantitative values are objectively measured. 2 individuals or more looking at the same phenomenon will have the same measure or the same count. And so then the numbers that you get, you can actually average those numbers together, and you can rank them. Like a higher number means attaining a higher measure. It means something. Quantitative values could be discrete or continuous, and I give you some examples here. In the case of categorical, values in particular categories are given a particular number that are assigned subjectively. So 2 different people might come up with 2 different numbering schemes. And qualitative values may be nominal or ordinal. Nominal means that there's no ranking of numbers. And ordinal mean there is a ranking that matters. The numbers, the higher the number, it's higher than the lower one. Okay, the order matters. It means something. Okay, so I provide some examples here, and then below that I give you an exercise to do. So try that exercise. Give you 10 minutes. And we'll come back. So try this exercise. On your own. Okay, when you're done, type your answers in order in the chat. You can number them. So I'll do the first one. Height of a woman, 18 and over. That would be that would actually be measured with a measuring tool, measuring stick or measuring tape. So that's going to be quantitative. And because I could have a tool that has more precision, so quantitative, because of that would be continuous. It's possible. This column I reserve so you can put some values in case there's some confusion. You want to clarify how your interpretation of the variable. The number of whole hours a student studies. Whole hours is a key word. The variable is hours of study, but the whole hours is very particular. So it means that I cannot study a student. We're not going to record if a student studies for a fraction of an hour. So this is also quantitative because time can be measured. And people would agree on the time that passed if they all measured it. So that would be quantitative, and because it's whole, however, that would be discrete. Place of runners in a race. Now if that's a variable, I didn't say, notice, I did not say the time of running a race. I said the place. The place would be considered categorical. The other word for categorical is qualitative, but it's easier. I find it easier because it's further away from sounding like quantitative. I use categorical. So it's categorical, and since the order does matter, the one with a higher place would have a number 1, right, closer to number 1. So order does matter, so we would say this is ordinal. Response to, do you like multiple choice questions? So you have to think, what are the possible answers? Yes, this is what I use this column for. No, or maybe you have no comment, or no comment. So there's 3 possibilities, which are really, they're just seen as categories. These are 3 different categories. I'm running out of space. Okay, so that's categorical, but then the question is does the order matter of these options? Okay, first of all, these are not numbers, but I could assign numbers. I could say yes is 1 and no is 2 and no comment is 3. And do the numbers mean anything? Like, would another person who was assigning numbers have to assign them in the same way? Well, no. in that case, they're nominal because the order doesn't matter. Okay, you're going to do the next two. Tell me what the answers to the next two are. You do the next two. Type it in. Okay, no comments. Come on. What's the score on a test? Score on a test. So provided this is a test with a rubric that anybody could use to grade. Okay, so there's a scoring sheet, or there's answers that are correct. Then this would just be quantitative. And I mean, it could be continuous. You could have 80.6%. You know, there's nothing stopping that from happening, except maybe a professor wants to round, or a teacher wants to round the scores up to whole numbers. I didn't specify that, so I'll take the broader answer. That would be continuous. So it's quantitative continuous. That would be the answer, unless if the assignment was A, B, C, D, if that's how the grades were assigned. In that case, those would be considered categorical and ordinal. Very important. The kind of variable you have will determine what you can do with these numbers. So for A, B, C, and D and F, it's difficult to put those letters together in a way to come with an average that's precisely meaningful. You know, they translate letter grades into GPA grades, into GPA scores, but in general, it's not going to get you back so easily to a letter grade. So we don't, you know, if it was like this, if you were thinking of a letter grade, we would call that categorical and ordinal, and we wouldn't easily be able to average values. But a score in general, where you imagine the results are like 80% or 80.5%, as an example, that would be quantitative and continuous. Salesperson rank, best to poorest. Best would be a higher rank, so order will matter relative to any of the ones below it, right? And the poorest would be worse than the ones above it. So this is going to be qualitative or categorical. And ordinal. All right, so the answers actually are on the next page. I usually give you the answers. And then, oh yeah, those are the answers there. And with some examples I provide for my understanding of what values the variables take. And I will end off with this quiz here. I would like you to try this quiz. I will give you 10 minutes. After that, we'll review it, and then I will play these videos for you that we have. The videos are the source of information for which the notes reference. Okay, so there's lots of referencing back to the videos, so you need to watch the videos first. And then on Thursday, we'll go over details of the notes that are not in the videos, as well as review the videos, comments as well. Okay, so attempt this quiz. You all have a copy. Same idea. These are 5 variables, and I want you to identify the type and subtype of variable. Are they quantitative, categorical? If it's quantitative, is it discrete or continuous? If it's categorical, is it nominal or ordinal? So give that a try. Okay, I'm taking a break, 10 minutes. Well, I'll get a break, you guys. Work on it. You can write your answers in the chat. All right. These exercises are only really meaningful if you try them on your own. You'll appreciate how challenging they are